Question number 36. We have to check the convergence of this series n square plus 1. So we can solve this problem by using comparison test. Here if we assume that xn is equal to nth term of a given series is this, we can choose another series yn such that n raised to the p upon n raised to the q. Here p is the highest power of n numerator, that is 0, and q is highest power of n in denominator, that is 2, so it is n square, so it becomes 1 upon n square. So our series yn is 1 upon n square. Then by using limit comparison test, L is equal to limit of xn upon yn, so it becomes limit of here limit always n tending to infinity, so this is xn is 1 upon n square plus 1 upon 1 by n square, so this becomes limit of n square upon n square plus 1, so this becomes limit of 1 plus 1, so this becomes limit of 1 upon 1 plus 1 by n square. If we put n tending to infinity, this becomes 1 plus 1 by 0, so this is 1. Here limit is finite and non-zero, therefore by comparison test both series converge or diverge together. But we know that series 1 by yn is 1 by n square, this is p series with p is greater than 1, therefore this series is convergent series. So this implies by comparison test our xn is also convergent series. Next question, that is question number 37. We have to check the convergence of this series. Assume that nth term of this series is this is not assumption, this is actually nth term of given series. So this is xn is equal to root n upon n plus root n. So we are choosing another series of yn is in the form of n raised to the p upon n raised to the q, where p is the highest power of n in numerator and q is the highest power of n in denominator. So this becomes n raised to the 1 by 2 upon n raised to the 1. The highest power of n in denominator is 1, so this becomes 1, so this series becomes 1 upon n raised to the 1 minus 2, so this becomes 1 upon n raised to the 1 by 2, so this series is 1 upon root n series. So we can take the ratio of these two, so this implies limit L is equal to limit n tending to infinity xn upon yn, so this becomes limit n tending to infinity root n upon n plus root n into root n. So this is series xn upon yn, so this root n becomes n, so this is n upon n plus root n. So this can be written as limit of 1 plus root n by n. If we put limit, then this becomes 1 plus, this becomes 1 upon 1 plus 0, so this is 1. So this limit is finite and non-zero, therefore by by comparison test both series converge or diverge together. Therefore, but our series of yn is a p series with p is less than 1. Here value of p is 1 by 2, therefore this is divergent series. This implies this is also a divergent series. This is also divergent series. Next question, question number 38. We have to find the relation between p and q such that this series is convergent. Here we can take nth term as n plus 1 raised to the p upon n raised to the q. This is nth term. So we can choose another series of yn is in the form of n raised to the x upon n raised to the y, where x is the highest power of n in numerator. Highest power of n in numerator is 1 upon n raised to p, highest power of n in denominator is q. So our nth term of yn series is n raised to the p upon n raised to the q. So by limit, so by comparison test, our L is equal to limit of xn upon yn. So just write nth term of series xn, that is n plus 1 raised to the p upon n raised to the q upon series yn. So if we can write this as n raised to the q upon n raised to the p, so n raised to the q get cancelled, so this becomes n plus 1 raised to the p upon n raised to the p, so this is become limit and tending to infinity. Remember here limit is always and tending to infinity. So this can be written as 1 plus 1 by n raised to the p. So as n tending to infinity, this limit is 1. So this is finite and non-zero. Therefore by comparison test both series converge or diverge together. But when it is given that this series is convergent series, that is our yn is convergent. Yn is series n raised to the p upon n raised to the q. This can be written as 1 upon n raised to the q minus p. As this is convergent, this implies q minus p is greater than 1, because this is the p series, and for convergence of this series our q minus p must be greater than 1. So this implies q is greater than 1 plus p. So this is our correct